contribution of scientists to our understanding of mass, momentum, and energy conservation. Presented by Sean A. Brent Calyanga and Diane Rose Dando. Mass, momentum, and energy are three quantities that can be conserved. In physics, when we say a quantity is conserved, it means that after an interaction or a reaction, no part of that quantity is lost. So, in physics, the concept of conservation refers to the preservation of certain quantities before and after interactions or processes. When we say a quantity like mass, momentum, or energy is conserved, it means that the total amount of a quantity remains the same before and after the interaction, even if its form or distribution may change. In simpler terms, nothing is lost or gained in terms of that specific quantity during the process. It is merely transferred or transformed. So, whether it's mass, momentum, or energy, their total values stay constant throughout the interaction.
Law of conservation of mass. The law of conservation of mass states that mass is an enclosed system is neither created nor destroyed by a chemical reaction. Thus, in a chemical reaction, the mass of the reactants must be equal to the mass of the products. So, we said that the conservation of mass states that in a chemical reaction, mass is neither created nor destroyed. For example, the carbon atom in coal becomes carbon dioxide when it is burned. The carbon atom changes from a solid structure to a gas, but its mass does not change. Below are the people who had contributed to the understanding of mass and its conservation. Ancient Greek philosophers believed that nothing comes from nothing, which implied that everything in the present had come from an origin. Nasir al-Din al-Tusi was a Persian polymath who wrote that a body of matter could not disappear completely. It could only change its form, condition, and other properties. These changes could turn it into a different form of matter. Mikhail Lomonosov was a Russian writer and polymath who disproved the phlogiston theory, which assumed that matter contained phlogiston, a fire-like substance that existed in combustible materials. He showed in an experiment of burning metals that the mass of metals remained the same after burning. Antoine Lavoisier proposed the law of conservation of mass. This law states that in a chemical reaction, the total mass of the products is always equal to the total mass of the reactants, and atoms are neither created nor destroyed, but rearranged to form new substances.
Law of Conservation of Energy. The law of conservation of energy states that energy cannot be created or destroyed. It can only be transformed from one form to another. Hence, the total energy of an isolated system never changes. In simpler terms, energy is always conserved, even though it may change its appearance or location within the system. So here are the scientists who had contributed to the development of the law of conservation of energy. First is Galileo Galilei. Galileo Galilei was an Italian astronomer and physicist who has studied an interrupted pendulum. Galileo Galilei's study of the interrupted pendulum was a crucial demonstration of the conservation of energy. By observing the pendulum's motion, he showed that the total energy of the system remained constant throughout the oscillations. So next is Christian Huygens. Christian Huygens was a Dutch mathematician who published his laws of collision. He noted that the kinetic energies of colliding objects were the same before and after the collisions. So, Christian Huygens' laws of collisions, also known as Huygens' principle of conservation of momentum, states that the total momentum of system of colliding objects remain constant before and after the collision, provided no external forces act on this system. Next is Gottfried Wilhelm Leibniz. He is a German polymath and philosopher who used Huygens' work on the collision to derive a mathematical formulation for energy that is related to the motion, kinetic energy. It is called vis viva, which is the Latin word for living force and represented as mv2. So, Leibniz's work laid the groundwork for the development of kinetic theory of gases and contributed to the broader understanding of energy in physics. So next is Emily du Châtelet. Emily du Châtelet performed experiments where she dropped a ball into soft clay at different heights. She learned that the ball kinetic energy was proportional to the square of its velocity, and the deformation on the clay was proportional to its initial potential energy. She then proposed that energy is different from momentum. So, ang kanyang pananaw ay nagbibigay daan sa mas malalim na pag-unawa sa kalikasan ng energy at sa mga relasyon nito sa pagitan ng iba't ibang anyo ng energy or yung different form ng energy. Next is si Albert Einstein. Si Albert Einstein, he developed a theory that united the concept of mass and energy. Einstein's energy-mass equivalence implies that neither mass nor energy are separately conserved, but they could be interchanged. The total mass energy of the universe is conserved. So, one of the key insights of his theory was the concept of mass energy equivalence, famously expressed by the equation E equals mc squared, where E represents energy, m represents mass, and c represents the speed of light in a vacuum. Next is the law of conservation of momentum. Just as mass and energy are conserved, momentum is also conserved. The law of conservation of momentum states that the total momentum of an object does not change. It remains at rest or in motion with constant velocity if there are no external forces acting on it. So, momentum. Ano nga ba muna yung momentum? Pag sinabi nating momentum, it is a fundamental concept in physics that represents the product of an object's mass and its velocity. This vector quantity, meaning it has both magnitude and direction. In simpler terms, momentum is the strength of force gained by an object in motion or as a result of a series of events. So, below is a list of scientists who have contributed to the development of the law of conservation of momentum. First is Jean Buridan. Jean Buridan was a teacher and philosopher who first used the term impetus to signify the notion of momentum. According to his theory, an impetus sets an object in motion, and it increases as the object's speed also increases. So, this concept is significant because it laid the groundwork for the development of modern momentum theory, which is a fundamental principle in physics. Next is René Descartes, René Descartes was a French philosopher and mathematician who proposed that the total quantity of motion of the universe is conserved, and it is equal to the product of the object's size and speed. Descartes' notion of the conservation of quantity of motion laid the groundwork for later developments in the understanding of momentum and its conservation in physics. His ideas contributed to the gradual refinement and evolution of scientific concepts over time. Next is John Wallis. John Wallace was an English mathematician who suggested the law of conservation of momentum. This law states that a body will remain at rest or in motion unless an external force applied to it is greater than its resistance. This statement is similar with the first law of motion of Sir Isaac Newton. So, ano nga ba ulit yung first law of motion ni Sir Isaac? Sabi doon, an object in motion tend to stay at motion and an object at rest tend to stay at rest unless acted upon an unbalanced force. So next is lastly si Sir Isaac Newton. So he was an English physicist and mathematician who defined the quantity of motion as a product of velocity and mass and later identified it as momentum. He implied that when no force acts on the object, the quantity of motion is conserved. So, in other words, Newton recognized that the product of an object's mass and velocity, which we now call momentum, is a conserved quantity in the absence of external forces acting on the object. This laid the foundation for the modern law of conservation of momentum, which states that the total momentum of a closed system remains constant unless acted upon by an external force. And that's all for our presentation. Thank you so much.